Now we come to the beam forming and beam steering. Massive MIMO is a key 5G technology. In this technology, there are a large number of antennas that are basically installed on the base station, and these antennas, which are called as the antenna array, basically work together in order to improve both coverage and the data rate of the mobile users that are present in that cells. In the context of 5G, the term massive MIMO and the beam forming are often used interchangeably. And why is it so? We will come to that. In order to understand the concept of massive MIMO, it is important to discuss what is single user MIMO and what is multi-user MIMO. In the case, this figure A is of single user MIMO. In the case of single user MIMO, there are 4 antennas. In this case, there are 4 antennas at the transmitter and 4 antennas at the receiver. So we call it as the single user MIMO as of 4 by 4 order, and here we have one transmitter and one receiver. Now there are 4 streams of data that are being transmitted by the transmitter. For example, this antenna is transmitting a stream of 10 megabits per second. Similarly, this antenna is also sending a stream of 10 megabits per second, and each of these antennas is sending a stream of 10 megabits per second. So when these 4 streams are received by the receiver is able to differentiate between these 4 streams. So we have the data rate of 40 megabits per second because these are 4 different streams. But when we talk about the channels that are being used in the time domain and the frequency domain, the same channels are being used by all these antennas. So within those channels we get a 4-fold increase in the data rate. Now when we talk about the massive MIMO, in this case of the massive MIMO, the example that we are considering, 2 streams of 10 megabits each are going to the receiver 1 and 2 streams of 10 megabits each are going to the receiver 2. So receiver 1 has a data rate of 20 megabits per second and receiver 2 has a data rate of 20 megabits per second. So it is multi-user MIMO because there is one transmitter and there is more than one receivers that are receiving those streams. Now these MIMO techniques are basically specially suitable for wireless environments or wireless channels where we have lots of multipaths and there is lot of scattering. So the performance of a MIMO system is maximum in the case of wireless channels where we have lot of scattering and we have lot of multipaths. Now, how this MIMO technology is affected by the change of frequency that is being used for the transmission. If we are using the frequencies that are below 6 gigahertz for the communication, in that case these frequencies are scattered a lot and there are many multipaths that are produced, and so this means that these frequencies are specially suited for the MIMO. And in the case of 5G we can go up till the order of 8 by 8 MIMO for these frequencies that are below 6 gigahertz. But when we go in the frequencies that are above 6 gigahertz, which is also known as the millimeter wave band, so these frequencies are attenuated a lot, and as these frequencies are more directional, so we have less scattering and hence less number of multipaths are produced. So the maximum order of MIMO to which we can go for these frequencies is 2 by 2 MIMO, to which, but on the other hand, due to the directional nature of these frequencies, these frequencies are well suited for the beam forming. However, want to remind you this, that MIMO and beam forming are not exclusive to one another. Like we can have the case where on a device some antennas are being used for MIMO, and while the other antennas are being used for the beam forming.